This is the second video where we're going to be applying roots, and we're going to start with the distance formula today. The distance formula is actually based on the Pythagorean theorem. For instance, if you wanted to find the distance from, say, this point to this point, one way to do it would be to consider this to be a right triangle, with this being the hypotenuse. And here would be one leg length, and here would be another leg length. And then you could square the leg length, add them together and take the square root, and you'll have the length of the hypotenuse. And that's exactly what this is. So to use the distance formula, we begin kind of like we began the slope formula. You're going to need to pick a point and call that x1, y1, and then pick another point and call that x2, y2, and then simply fill in the values and follow the order of operations. For instance, say I wanted to find the distance from 8, 0 to 0, 6. My first step would be to decide who's going to be my x1, y1 and who's going to be my x2, y2. And it really doesn't matter who's who, so I'm just going to say I'm thinking of it this way. And then I start with the distance formula, and this is going to be x2 minus x1. And so my x2 is 0, and my x1 is 8. And then I take y2 minus y1. Well, my y2 is 6, and my y1 is 0. And see, that's why I kind of like to write this up here for a while, just to make sure I get everything right. And then at some point you don't have to do it anymore because you've worked so many problems. Now that I've filled in values for x1, y1 and x2, y2, I can just follow the order of operations. I have to do what's in parentheses, and so I subtract. And then I have to square before I add. And then I add. And last, I take the square root of 100, which is 10. And so that's the distance from this point to this point. It's your turn now. Can you find the distance from this point to this point? Okay, so it's this distance right here. And I have to decide who's going to be my x1, y1 and who's going to be my x2, y2. And I'll just do what I did last time. Same thing. I start again with my formula. My x2 minus x1, well, here's my x2, negative 4. And then I'm going to subtract x1. And my x1 is negative 10, so I fill that in. Plus y2 is 2, so that goes here, see? And then y1, well, that's 6. So that goes here. And now I'm going to follow the order of operations. I have to start inside these parentheses. This is going to be negative 4 plus 10, which is going to be 6. And this is going to be 2 plus negative 6, which is negative 4. And then I square 6 to get 36. I square negative 4 to get 16. I add them together, and so the distance turns out to be the square root of 52. And if you use a calculator, you'll find that this is approximately 7.21. So this is the exact distance, and this is approximately how long it is. Try this one. Notice here I'm going from here to here. And I'm wondering what this distance is, and hopefully it's about 8 units, because it's just this line, but let's see if the formula works. I'll just use this as my x1, y1, and this will be my x2, y2. And so I'm going to fill in x2 minus x1 will be 8 minus 8. And then y2 minus y1 will be 0 minus negative 8. Order of operations, I have to start in parentheses. 8 minus 8 is 0. 0, and this will be 0 plus 8, which will just be 8, so I'll have 0 squared plus 8 squared. And when I square those, I'll get 0 plus 64, and then the square root of 64 is 8. And so, like we were expecting, the distance from this point to this point is 8 units. And here's one more. Look at all those sign issues. I'm going to use -2 for my x2, -8 for my x1, -6 for my y2, -4 for my y1. Then when I simplify inside these parentheses, it's going to be -2 plus 8, which will be 6, and -6 plus 4, which will be -2. And then I'll square and add, and I'll find the distance is the square root of 40, or approximately 6.32. Well, that will conclude this video where we use the distance formula to practice applying square roots.